Hello and welcome to my first Trailmakers logic video. I've gotten a lot of questions on a very specific set of circuits that I use quite frequently, and they're incredibly useful. I use them a lot. I use them like multiple times per every single logic build I make. So I just decided to make a video going over them so I didn't have to constantly explain how to make this in text every single time somebody in the Trailmakers Discord asked me what the heck I'm talking about. Okay, so basically, the two circuits, or in this case, technically functions, because these are actually math functions, are the integral and the derivative. If you're at all experienced in calculus, you're gonna know basically exactly what I'm about to do. So I'm just gonna make a accumulator here. Keep this number in mind, this 23.20. It is going to come back later, and it's going to be important. So we have an accumulator. It goes up, it goes down, it does normal accumulator things. So what we're gonna do is we are going to first talk about derivation, and we are going to derive our input here. So what you need to do to derive an input is you simply take your input, multiply by -1, and then multiply the negative input and the input. So your input goes into this gate and that gate, and this gate's -1, this gate is 60, and then you can output that, and that will give you the change in the input. So as you can see, our input is changing by 23.20, which you will remember is the multiplier of the accumulator that we just made. And what we can do is we can actually just undo our derivation by putting it into another accumulator. Accumulator is just the accumulator block just does a integration by time. That will be useful later once we get into specific use cases of integration and derivation. So if we just output that 2, we'll see that our two accumulators are equal, and these two operations are in fact canceling each other out. So we're taking our initial value, and then we're getting the change in that value, and then we're turning that back into the value by integrating it back into another accumulator. They perfectly cancel out. No matter how many times you integrate, you can always derive back to your initial number, or vice versa. They just cancel out, like multiplication and division, or addition and subtraction. They're just a PEMDAS pair, basically. What you can also do is, if you want to get rid of certain data, so a use case of this is the jump asymptote of the actually, let me pull out an example really fast. Let's save this. I'll come back to that later. The jump of the angle sensor and compass. They both have this. I get a lot of questions about how the heck you get rid of that. Actually, I went past the circuit I need. Where is it? This one. There we go. So basically, let me quickly. Actually, we'll just run it as is. So as you can see, the output of the compass is directly above the compass itself, and then the output of our accumulator is those two numbers. One of them is modulus, the other one is not. And as you can see, they're all equal once we get out of the weird range between like negative numbers and stuff. But as we increase, we get to 1, and then... do I have both of these modulo? Gosh darn it, I do. They're both modulus. Let me get rid of the modulo. There we go. So now, those two number displays next to each other, they're equal, and we can just keep going, and then if you've messed around with compasses, you know that it jumps from positive to negative here. As you can see, our circuit does not do that, and it in fact just stays at the same value. It does lose 0.02. It's just, this is an example. I've fixed that in later versions of the circuit. This is a really early version of me trying to do this. So it loses a bit of the data, but basically how this works is, let's see, we just derived, and then we just removed part of the data before integrating again. And if we didn't do that, if we just delete these two gates, we'll see that no matter what, our accumulated one is the same, because we're deriving and then integrating again. But having a product gate here allows us to selectively integrate and derive certain parts of the data, so that we don't have to, so that we can like selectively remove parts of the data, which is a useful. What we can also do with it, which is arguably the more useful stuff, we'll spawn this back in and quickly add a couple thrusters. Yeah, that's not great. And if we can actually, I'll leave the, actually, I'll just, no, yeah. I'll leave the derivative here because I'll just reuse the circuit. And then if we grab ourselves a speed sensor, put it on measurement, because this will output meters per second, and then we can, we'll just integrate this really quickly for comparison. And then we'll also derive it. So as you can see, if we move forward, our integration changes, but it does not change back. This value in the integration actually is our distance traveled in meters. So if we reach this yellow line, you can see it's basically 10 meters in front of where we spawn in. And if we just keep doing this, it'll always be 10 meters. I just overshot it completely, so we don't have the same number. But this is an incredibly accurate way of getting your distance traveled, and it's incredibly useful if you want to make like a guided missile or like an odometer. There are a lot of uses for this. You can do basically anything with that. But if we instead look at what our derivation is doing, on the other hand, it looks like a random number because it kind of is. Let me add a sail to this so that we can see what's happening better. Let me add some drag. Actually, I think one of these powered tail fins is probably strong enough. So if if we see we're at max speed, but okay, let me get a longer run up so that I can keep talking. So if we keep looking at that number gate, we can see that the number goes up and then basically becomes 0, and you can see our speed is basically not changing. What the derivative here is doing is it's actually finding us the acceleration of our vehicle, which is honestly really cool. If you ever needed like the G number, you can just do that in game, calculate it right there and then. You can also, you'd have to get the G number, you'd actually just divide it by 10. That's beside the point. You can also use that to make a better cruise control, because I saw that the devs were showing off a cruise control they built when they announced some of these new logic blocks. They were not using this method, so it was kind of jank. You could make a better one using this. I was just editing the video here, and I realized that I completely forgot to mention how the calculus functions interact with units, because it is very important that you understand how this works. So the derivative function will divide whatever your units were previously by seconds. So if you had meters, it would become meters per second. And if you had meters per second, it would become meters per second squared. And with the integral function, your previous units are multiplied by seconds. So if you had meters per second, you would now have meters, as you could see with the integration of the velocity example. Or if you had the acceleration, integrating would yield the velocity, because meters per second squared times seconds is meters per second, which is velocity. Now back to the video. Another big use of the derivative is in PID loops. So this is my auto-balancing auto-balancing engine vehicle. So it uses the engine to balance. There are no gyros or anything. You can count all the power cores yourself. And it just uses the derivative of the angle sensor to balance itself a lot smoother. As you can see, this thing is hella smooth. And it's really stable. And it's really fun to mess around with. So the applications of the calculus in this game are honestly endless. And there are a lot more that I haven't covered here that I will be covering in future videos. So that, because like, why not? And if y'all have any logic questions or anything in general, feel free to leave questions, comments, concerns in in the comment section below. And as always, just like and subscribe. I'm kind of new to this, and any subscriptions now will like mean the world. See you next video, and I think I'll be showing off some of my newer ways to get rid of the servo, I'm not servo, angle sensor, like jump, so that you can make really good stabilizers for your tank turrets. And with that, I'll see you in the next video.